guys, we're starting the addition and subtraction of algebraic fractions. We're going to jump straight into an example. We're going to follow the steps that are on your note that I sent you. Okay, so first thing we need to do when we want to add or subtract fractions is find the LCD. Now with normal fractions, that's easy, but with algebraic fractions, it gets a little bit tricky. We did dedicate a lesson to finding the LCD yesterday, but let's just do it again now. So first off, we find the LCD. In order to do that, we have to first make sure we have a single term on the top and the bottom of each fraction by factorizing, or if you can't factorize, by putting brackets around it. And then after we've done that, we can find the LCD. I'll remind you how that works. Okay, so to find the LCD here, firstly, make one term over one term. So the top of my first fraction, I can't factorize that, so I put it in brackets. The bottom of my first fraction, I can factorize that. It's common factor factorization. I'm taking out a 3. Okay, next fraction. That's already one term over one term, so I don't have to change anything there. And then my last fraction is one term at the top already, and at the bottom I need to factorize that, and that is once again common factor. I'm going to take out x and y, and I'm going to be left with x plus 2. Okay, now to find the LCD, we split it into 3 parts. We split it into the coefficient, find the lowest common multiple of the coefficients. Then the letters, you write down every letter present with the highest exponent for each. And then the brackets, you write down every different type of bracket present with the highest exponent for each bracket. So starting with the coefficients, I've got 3 and 6. The lowest number that 3 and 6 can both go into is 6. So my lowest common denominator starts with 6. Then the letters, the free letters, not the letters trapped in a bracket. I'm talking about these letters that are free. Okay, those letters, I've got x's and I've got y's. And we include the highest exponent of each letter. So the highest exponent of x is 1. The highest exponent of y, though, is 3. So we can say that this is going to be x to the 1 and y cubed. And then onto the brackets, we have x plus 2, and we've got the same thing there again. So we write our brackets x plus 2. And that is our LCD here. Okay. Then, just like with normal fractions, your second step is to convert all of the fractions to have the LCD as the denominator. And we do it the same way we do with normal fractions. You ask yourself, what must I multiply the denominator by to get to the LCD? When you figure that out, you multiply the top by the same thing. Okay, so here, what must I multiply 3x plus 2 by to get to 6xy cubed x plus 2? So the way you figure that out is you figure out what's missing. How do I get from 3 to 6? I multiply by 2, so I need to start by multiplying by 2. Then, what else is missing? I'm missing the x and the y cubed, so I need to multiply also by the x and the y cubed, but I have the bracket, so I don't need to multiply by the bracket. Next fraction, I've got my 6 and my y cubed, but I don't have the x or the bracket, so I need to multiply by the x and the bracket. So multiply by x, x plus 2 at the top and at the bottom. And then my last fraction, I've got my x, I've got one of these y cubes, and I've got my bracket. So first off, this is a ghost 1 here, so I must times by 6 still. I've got the x, and then how do we get from y to y cubed? What do I need to times y by to get to y cubed? I'm hoping you know the answer to this. I need to times it by y squared. Y times y squared will give me y cubed. So I'm timesing by 6y squared at the top and at the bottom. And I don't need to multiply by the brackets because I already have it. Okay, so now let's go and actually write down the answers for each of those. That means this becomes 2xy cubed times x minus 3 over my LCD of 6xy cubed x plus 2 minus. These fractions are all going to be over the LCD, so I'm actually going to go and write it in now. Okay, so my second fraction, the numerator I was timesing by x plus 2, so 5x times x is 5x squared, and then my brackets x plus 2. Okay, and then my third fraction, this one's easy. 1 times 6y squared is just 6y squared. Okay, now, as we would do with normal fractions, we would now write our answer, okay, with the LCD as the denominator, and at the top, our numerator, we would write down the sum of or difference of, depending if it's minus or plus, our numerators. Okay, so we would sum the numerators at the top, and at the bottom goes our LCD. So we write it all as one fraction, and we're going to get my denominator is 6xy cubed x plus 2. My numerator, I write down the sum of those. Now, those are all unlike terms, so I'm just going to write them down as they are. 2xy cubed x minus 3 minus 5x squared x plus 2 plus 6y squared. And then lastly, and this is in part of step 3, is to multiply out numerators and add like terms. Okay. So, distributive law on the first one. I think I need to maybe tilt you down a bit. Okay, so distributive law on the first one. Whoopsie. Okay, distributive law on the first one. I'm going 2xy cubed times x and then times negative 3. So I get 2x squared y cubed minus 6xy cubed. Second one, negative 5x cubed minus 10x squared. And last one is plus 6y squared all over 6xy cubed x plus 2. And can we add any of those? No, none of these are like terms, okay? But sometimes when you get to this stage, you'll have some like terms at the top, and then you can add those together. Okay, just hang on a second. Okay, y'all guys, that's it. So that is our whole example with the steps you need to do. It's the same steps every time. Sometimes you might run into something a little bit weird where you can simplify it before you start. So I'm actually going to erase this and show you what I mean. Let's say this question was actually, didn't have to erase it, was actually 5xy over 6y cubed. Then before you even start, you could have simplified this fraction to be 5x over 6y squared. Okay? So always keep an eye out for that. You might be able to simplify something before you start. Okay, and that's basically it. So I know it looks terrifying, but the more you practice it, the easier it will become. You'll see it's just exactly the same thing as working with boring grade 8 fractions. Okay, just a little bit more exciting, but it's the same method, it's the same logic. Okay, please do let me know if you get stuck. Your questions are at the bottom of that note.